Now, part F is about the statistical reliability and validity. So it's just about how we can say whether the test, whatever we do, is reliable, whatever source we have, and whether it's valid or not with respect to R. What was R? It was the coefficient of correlation. So how it can be reliable, how you can say whether it's reliable when it shows the consistent result. So how we can do it, for example, let's go with the example. If I, for example, take from you quiz, and if I want to check whether it's reliable or not, I may give you the same test again to you. So I will check whether you show the same results or not. But there may be one problem there. You already know the question, so you may show the higher result. Or another way you can check the reliability is by the parallel forms. I will ask from the same topic, for example, from statistics or from probability, but different questions. Same chapter, but different questions. So again, if it shows the same results, you may say that it's a reliable with respect to correlation, strong correlation between two variables. And about the validity, it considers how about the accuracy, how accurate a variable predicts another one. So it can be content validity. So, but if I do a test for you, for example, from probability, is it valid or not? How I can check it? Am I asking each part which I taught to you, which I showed to you? If I'm asking each part, it's a content validity. How criterion validity? What can be? Whether, for example, my probability test from chapter probability test, the result does it show that you know all the statistics or not? So it's a criterion validity. Do you get my point? For example, statistics is a big chapter. It has inside 5 or 6 chapters. One of them is probability. So I'm asking you, after taking these exam or these quiz, is it valid that I can tell you that you know the statistics or not? No. So in the criterion validity, you should consider whether your correlation valid or not, whether it shows the dependent variable. For example, we had what independent here, or explanatory, and we also had dependent. So whether it is valid or not, does it show my measures correctly, accurately? So this type of parts are very important for your IA also. You can discuss in your IA. Most of you are doing about the correlation, I guess. So this type of stuff you can include in your IAs. Now let's see some questions from the book. For example, for each of these scenarios, determine the type of reliability being considered. So what kind of reliability we said there is? Test, retest. So I ask again the same, retest. Or the parallel form. I ask from the same topic but different questions. A language teaching app randomly selects 10 Spanish sentences from Frederick to translate into English every evening. So what kind of, is it test, retest? Is he asking the same sentences? No, it's a different sentence, randomly. So it's a parallel form. Lucien measures his resting blood pressure every morning as soon as he wakes up. So it's a test retest. So he does it the same with the same tool. Let's say he's not doing it a different way. He's doing the same. So test retest. The longest distance thrown by each javelin thrower in a track and the field team is recorded at the end of each training session. So after each training session, they check the same way the throwing distance. So it's a test retest. They are doing it the same way. They are not doing different testing or different type of measuring the distance in the same way. The ATP tennis professionals assign ranks, so they are giving the players the ranks. As we know, for example, the tennis players have their ranks and the number of Grand Slams. The following table, 15 male singles. So here's the rank of the players. The names are not important, just the ranking and the number of slams. Calculate the Pearson product moment correlation between the player's ATP rank and number of Grand Slams. Okay, let's try to solve it. So I have to input the numbers. We go to the menu, statistics, and let's input the numbers. 1, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10, and 15. In the second column, I will write their Grand Slams. 14, 17, 20, 0, 1, and there is 0. Okay. Now, let's calculate. We don't need to draw the graph. We can go with the regression. Let's see the x. And let's check what R is. R equals to minus R equals to, what was it, minus 0.687. So there is a negative kind of moderate, between weak and moderate correlation. Yes, so the second question asks you, explain why criterion validity is being considered here and identify the criterion variable. So what's a criterion validity was, whether they're related or not, whether the rank predicts the number of Grand Slams. So as we can see, it's a weak one, negative weak. So the criterion variable, what was it? Number of Grand Slams. Whether the rank explains the Grand Slams or not. So this one is criterion variable. Grand Slams, the number of Grand Slams. Comment on the criterion validity and of predicted variable. So what we can say, there is a negative weak correlation between the variables and has a little criterion validity because of these numbers. Because it's big, we can say that there is a little criterion validity. So go to your book, check. There is also one problem, solved problem there. Check also, and there are some reading part. You can read it again.